today? All right. Today we're going to review multiplying polynomials. And the reason we're going to multiply polynomials is because the next thing we need to do is learn how to factor. And we're going to, and factoring is undoing multiplying. Okay, here we go. So factoring is undoing that multiplication. So before we undo multiplication, we are going to review the multiplication. The things that we are going to be multiplying and factoring are polynomials, and polynomials are expressions with many terms. Don't do that. And even though it is technically with many terms, you can have a polynomial with one term. What do you think it's called? Monomial, yep. Good context clues there. Monomial is going to be a polynomial with one term. Binomial would be two terms. And trinomial? Three terms. Good. Okay. So first we're going to just practice distributing. So when we distribute, you know, you have to multiply the outside to both parts of the inside. When you multiply an x times an x, remember that when you multiply, you are adding exponents. So x times x is x squared. Hello. All right, so if I do 3x times x, I get 3x squared. And then 3x times 4, I just multiply the 3 and the 4, and I still have this x here, so I have 3x squared plus 12x. Take a minute to try the next one and compare with your neighbors. All right, 4 times 2 is 8. X to the 1 times x to the 2 gives you x to the 3.
Bro, I said that. I said that on here.
Because remember, when you multiply, you're going to add your exponents, okay? Now, here's my minus here. Anything times 1 will be itself, so that should just be 4x. Now, okay, so some people like the box method. Some people like FOIL, which is also just distributive property. FOIL is exactly the same as distributive property. Distributive property. All right, I'm gonna show you both. I'm gonna warn you, I like distributive property, and that's how I'm gonna do most of my examples, but you don't have to. Last year I had students who did box the whole year. It worked for them, and that's fine, okay? So in the box method, you draw this 4x4 box. It's the same thing that you do in biology with your Punnett square. And the 3x plus 2 will go here. And then the x minus 1 will go here. All right, and what the box does is it just reminds you to multiply everything in the first parentheses times everything in the second parentheses. So it just makes sure that you don't miss something.
So that'd be like in the first box, top left, it'd be 3x to the second power.
Yeah.
Or a square.
Mm-hmm. All right, did you see that? So Michael multiplied the 3x times the x and got 3x squared here. All right, next we're going to do 2 times x, and that's just going to give us what? 2x. Good. 3x times negative 1, negative 3x. And 2 times negative 1.
Negative 2.
Negative 2. All right, now we know we're not going to leave our answer in the boxes, so let's think about how we're going to write it down. Let's give people a minute to make sure they have that.
Top left. So right.
Kind of, yeah. So when we write in standard form, you write the one with the biggest exponent first. So what's the one with the biggest exponent?
3x squared.
It's the 3x squared, thanks. Okay, and then we write the one with the next exponent, and we have two of them. And so what we're going to do is combine like terms. So I have to combine 2x and negative 3x.
X.
Negative 6.
Say it again, you're good. Okay, so first you said negative 1x, which was right. And then you simplified that to negative x, which is a simplified version. You can write either of those. You can write negative 1x or you can write negative x. Okay? They're both good.
Wait, why don't we multiply them?
Here,
We
because...
follow what it's saying to do in the end multiplication.
Yeah, well, we already did all the multiplying, and this is our answer. Now we're just combining like terms, that's all. So negative 1x or negative x, and then the negative 2. I'm going to do one with distributive property here, and these others, you can do them with box or distributive, whatever you want. Yes?
In what order are you supposed to do the boxes?
Top left. The 2 diagonals.
Do you mean for setting it up, or do you mean for the multiplying?
Multiply.
So it's basically like the column times the row. So this one would be this column times this row, and that would be this column times this row, you see? Okay.
And then for like applying it here.
Then it's top left and 2 diagonals.
All right. So FOIL, does anybody remember what FOIL stands for in math?
Function.
Okay. So it doesn't stand for distributive property, but it is the distributive property. It's like the order that you would distribute in. So it says first multiply the first times the first. So F is first. O is outer. Multiply the outer times the outer. I is inner. Do the inner times the inner. And L is last. Do the last times the last. Now, you don't have to memorize what they mean because it's exactly the same thing you get when you distribute. I'm just going to show you distributing. And if you don't love it, you can do box method for everything, okay? Here we go. The x distributes to the 5x and the 2. You see that? The x distributes to the 5x and to the 2. X times 5x is 5x squared. X times 2 is 2x. We're not done though.
Yeah, the negative 4.
Yeah, we have to distribute the negative 4. And so I'm just going to circle it so I don't lose track of the negative. And I'm going to multiply the negative 4 times the 5x and times the 2 also. So negative 4 times 5x is negative 20x. And negative 4 times 2 is negative 8. All right. I'm going to combine my two like terms here. And I'm going to bring down 5x squared minus 18x and minus 8. All right, you have 2 more problems on your page, and so you can use whatever method you want. I'm going to tell you the wrong answer to number 6 so that you don't waste any time on it. Here we go. All right. So distributive property for number 5, I'm going to do x times x, x squared. X times negative 2 is negative 2x. 2 times x is 2x. And 2 times negative 4, 2 times negative 2 is negative 4. And if you did box method on that, you should have gotten those same numbers in the boxes, right?
Yes.
Okay.
But we got the shorter version.
The shorter version. So what would be the simplified version?
X squared minus 4.
X squared minus 4. What happened with 2x and negative 2x?
They just cancel out.
They did cancel out. Well done.
It is very
Yeah,
short.
it's gonna
Oh,
like
it's
the
depends on
season.
the order.
Mhm.
Okay, that makes sense.
So smart.
All right. So the reason why x minus 3 squared is not x squared minus 9, and it's also not x squared plus 9, is because you cannot distribute a square when there's an addition or a subtraction here. So you can't just distribute that square. It doesn't work. Instead, what do we do? Stop there for a second because they requested the box method. I needed this set up and you gave me the hard part. Thank you. All right, so when you square something, you multiply it by itself, right? So if we want to multiply x minus 3 times itself, you write it twice. And then there was a request that we put it in the box method. Now you don't have to do box method. If you love distributive property like I do, you can use distributive property. That's all up to you.
So would it just be x3, x3?
Minus though, so it's going to be a negative 3, x, and then negative 3. Like that. All right, x times x is x squared. X times negative 3. Negative 3 times x, and negative 3 times negative 3. Negative 3x and negative 3x, do those cancel out? No. What do they make? Because remember, we're not multiplying, right? What kind of 6? Yeah, negative 6. So we're going to we move back 3, that's negative 3. And if you add another negative 3 to that, it moves you back 3 more, so it's negative 6. So we have x squared minus 6x plus 9. Back, we are factoring out a greatest common factor. So we're looking for the biggest thing we can divide both terms by. So only one of them has an x. We cannot factor out an x, but they both have numbers. What's the biggest number we can divide? Wait, I don't want you to tell me out loud. I want you to tell your partners. Tell your partners what's the biggest number we can divide 3 and 12 by? 4.
6.
Tell your partners the biggest number we can divide 3 and 12 by.
3.
Did you say 4?
No, you said 4. Yeah.
Okay. Maya, what's the answer?
3.
3. We can divide 3 by 3. We can divide 12 by 3, right? So 3 is the one. Okay, so the GCF is 3. We're going to factor it out, which means we're not going to get rid of it completely, but we're going to take it on the outside. We're basically undoing the multiplication that happened earlier. So we're taking out this 3 like this. And when you do it, you put the 3 on the outside of the parentheses. It's like we're undoing the kind of problem we just did. So 3x divided by 3 gives us just what? It gives us just x, because those 3's cancel. All right. Yeah, you should have done this in Algebra 1, but that was 2 years ago, so if you forgot, it's okay.
Plus 4.
And then plus 4. All right, take a look. Now it looks like the kind of problem from the front, right? You would multiply 3 by each of those things, you would distribute it, and you would end up with 3x plus 12. So we're working backwards now. Same thing for the next one. Think to yourself, in your head first, what's the biggest number I can divide 12 and 16 by? Some of us are better at dividing than others. You can use a calculator if you're like, I can't remember if I can divide 12 by 5.
We have to get a whole number.
Yes.
Okay.
Yeah, the point is that you have to get a whole number, okay? And then now tell your neighbors if you think you might know what it is. What can you divide 12 and 16 by? The biggest thing.
4.
You guys think it's 4? I think you're right. So GCF is 4. Whoa, doesn't want to. Oh, there we go. Okay. Oh, wait, I forgot something, guys. They both have x. Focus. They both have x, so we have to factor out some x's too. The first one has x squared, which is x times x, and the second one just has x. We can only take something out if it's in both terms. So we can take out what? It is 1x, but we're just going to call it x, okay? So we can factor out a single x because remember this x squared here is x times x, right? And this one is just x. So if I take out x like this, then these will cancel completely, like that. And this x will cancel out with this one. So I still have an x left on this one. 12 divided by 4, so actually your GCF is 4x. 12 divided by 4 is 3. And I still had one x that didn't cancel out. That goes there. Minus. Okay, the x is canceled. So 16 divided by 4 is 4. All right, so I do have to put the parentheses. And the thing that I factored out has to go on the outside. Okay. All right, so I saw a bunch of you divided by what GCF? 5 what? X, good. This is tricky because a lot of people, when everything cancels out, they're not sure what to do with that. But some of you are. So 15 divided by 5 is 3. X squared, of course, is x times x. And so one of those x's will cancel out with this. And we have one left. Minus, what is something divided by itself?
1.
It's 1, good. That's good.
Bro, I'm brilliant.
I know. All right, and then the thing we factored out goes out here. So that if we wanted to multiply it back, we would end up with 15x squared minus 5x.
Got to wrap these up.
Okay. In number 10, do all three terms have a b? No, so we can't divide by b. But we can factor out what number?
7.
7, good. So my GCF is 7. All right, so my 7 on the outside, and you should get 7b squared plus 2b plus 1. Don't forget your plus 1 there. All right. For those of you who are done with that one, take a look at the flow chart here. What we have just done is the first step in any factoring problem to look for a greatest common factor. They don't often actually have a greatest common factor, but if you overlook that step, then you might get yourself into a big mess trying to factor before you take out a greatest common factor. So always check for it. Don't be surprised if there's not one, but sometimes there is. Then your next step is to figure out how many terms you have, 2, 3, or 4, and that's going to help you choose your factoring method. Today, we learned this one, and now we're about to learn this one. Okay? So we don't know all these things yet, but we learned how to take out the greatest common factor, and now we're going to learn how to do difference of squares. Difference of squares is what happens when you have two factors and the middle term cancels out when you multiply them and you only end up with 2 terms. Look at the front. In which problem on the bottom did our answer have just 2 terms?
5.
Is it 6 or 5, guys? Which one does the answer have only 2 terms? 5, yeah, 1 term, 2 terms, okay? So what happened in this problem is the negative 2x and the positive 2x canceled out. Looking at your 2 factors here, what's unique about these 2 factors that was going to make those 2 middle terms cancel out? The plus and the minus, right? So we have a plus and a minus, and it's not like plus 5 and minus 10, right? We added and subtracted the same number. Okay. So when we add and subtract the same number, we end up with the difference of squares. And that's what these are all going to look like. They're all going to be x plus a number, and then x minus a number. And the reason we know this is because we're missing our middle term. The middle term canceled out, so that means it must be plus and minus the same number. Tell your group if you think you know what the number is for this problem, number 11. What number would we have a plus and a minus to that's going to give us this answer? X squared minus 25. All right, what do you guys think it is?
X is 25.
Okay, so there's going to be an x in there. It's going to make it 25. What number times itself will give us the 25?
5 squared.
5. So a plus 5 and a minus 5 will give us that negative 25. Right? That gives us the negative 25. And it gives us that middle term that cancels out. 5x and negative 5x will cancel out. And x times x gives us the x squared. Now the shortcut for this is just to do the square root of each term. So if I do the square root of x squared, that tells me that this is x. And if I do the square root of 25, that tells me that these two are going to both be 5. Let's look at number 12. You know what we forgot to do in this one was look for our greatest common factor, but we were lucky. Can you let him in, please, Andrew? We were lucky because there wasn't one. All right, so I'm going to factor out that 2 first. And now I have difference of squares because x squared is the square of x and 16 is the square of what number?
32. Oh, no, it's not.
16 is the square of what number? What's the square root of 16?
4.
4, yeah. So that means square root, I'm just thinking on the side here, of x squared is x. Square root of 16 is 4. And so the 2 stays on the outside, x plus 4, x minus 4. So we said there's no GCF for this. So we have to figure out how to factor this difference of squares. We have to think to ourselves, what is the square root of 9x squared? And what is the square root of 25? So, square root of 9x squared? 3 what? X. Good. Square root of 25? 5. Okay, so now you make your parentheses, and instead of starting with an x, it starts with a 3x. 3x plus 5, 3x minus 5.
I'm gonna study around this. That's what we find.
Okay, in 14, 15, and 16, here's a hint. All 3 of them have a greatest common factor. So before you start square rooting them, you need to first find the greatest common factor of each one, okay? While you guys are working on those, I'm going to be looking at your delta math. Oh. Okay. Factoring out 3x. So we said x cubed is x times x times x, and so one of those x's will cancel out with this one. The 3 will cancel out, and so that's going to leave you with x squared. And then over here, these x's cancel out, and 147 minus 3 is going to give you minus 49. And I'm going to put the 3x on the outside. Okay, so now you have to remember to do your square root. So square root of x squared is x. Square root of 49 is 7. So you should have 3x times x plus 7 times x minus 7. If you're a little bit behind, just try to focus on the one I'm doing right now, and you can go back and look at the others. So I'm going to factor out x because they both have x. The first term does not have a number, so I don't have a number to factor out. I can see that these two are going to cancel. And here again, I have x to the third divided by x, and that's going to give me x squared with an x on the outside, minus 81. So the x is going to be on the outside. What's the square root of x squared? It's x. What's the square root of 81? 9. You don't have to have them all memorized. You can just do square root of 81 on a calculator.
I like never fully learn my times tables, so.
This is not a multiplication class, so you can use a calculator. All right, greatest common factor of 12x squared and 108. It's 12? 12 goes into it? How many times? 9 times? All right, so the 12 on the outside and x squared minus 9. All right, square root of x squared is still x, and the square root of 9 is? 3. So you should have a plus and a minus, and then you're done.